Relation between the roots and coefficients of quadratic equation. Now see student, we have to learn relation between the roots and coefficient of quadratic equation. Now see, if alpha and beta are the roots of quadratic equation and a, b, c are the coefficient of the equation, ax square plus bx plus c is equals to 0. See, remember, you have to remember alpha and beta are the two roots and a, b, c are the coefficient. Then we can say sum of the root, that is alpha plus beta, is equals to minus b upon a. See, b is the coefficient of x and a is the coefficient of x square. So you have to remember student, alpha plus beta is equals to minus b upon a, and product of the roots, that is alpha into beta, is equals to c upon a. C is the constant and a is the coefficient of x square. So you have to remember alpha plus beta is equals to minus b upon a and alpha into beta is equals to c upon a. Question number 1. If one root of quadratic equation kx square minus 5x plus 2 is equals to 0, is 4 times the other, find the k. See, the quadratic equation, given quadratic equation is k square minus 5x plus 2 is equals to 0. Now comparing this with the standard form, that is ax square plus bx plus c is equals to 0, we get a is equals to 1, b is equals to minus 5 and c is equals to 2. Now see student, we have value of a, b, c. Now there is relation between alpha and beta, it is given in the sum. One root of the quadratic equation is 4 times the other. See, we know that alpha and beta are the roots of given quadratic equation, therefore alpha is equals to 4 beta. It is given, equation number 1. Now see, we know alpha plus beta is equals to minus b upon a, and see the b is minus 5. So minus minus of 5 upon k, minus minus become plus 5 upon k. Equation number 2, and this is by formula. Now we know alpha into beta, right? Similarly, we can substitute the value of alpha. See, in equation number 1, we have alpha 4 beta plus beta. That is equals to 5 upon k. 4 beta plus beta is equals to 5 beta is equals to 5 upon k. Now we can write this as beta is equals to 1 upon k. 5 get cancelled. Now alpha into beta, c upon a is equals to 2 upon k. Now in this is by formula. You can substitute the value of alpha. Alpha is equals to 4 beta into beta as it is equals to 2 upon k. That means 4 beta square is equals to 2 upon k, and we know that beta is equals to 1 upon k. So 1 upon k the whole. We get 1 upon k the whole square as 1 upon k square is equals to 2 upon k. Now see, you can solve this. You will get 4 into 1 by 2 is equals to k square upon k. K get cancelled. So k is equals to 2. That means value of k is equals to 2. So we can use formula alpha plus beta and alpha into beta. Question number 2. Find k if the roots of quadratic equation x square plus kx plus 40 are in the ratio 2:5. Quadratic equation is given and we have to find roots value of k. See the quadratic equation, x square plus kx plus 40 is equals to 0. Comparing with x square plus bx plus c is equals to 0, we get a is equals to 1, b is equals to k, c is equals to 40. Now see, we know that alpha and beta are the roots of given quadratic equation, and alpha is to beta, their ratio is given 2:5. See, ratio is given, that means student we can assume common multiple. So common multiple be n. So we can write alpha is equals to 2n and beta is equals to 5n. That means now we can write alpha plus beta is equals to formula minus b upon a. See, b is k, a is 1. So minus k upon 1, that is minus k. Alpha and beta's value, that is 2m and 5m. We get 2m plus 5m is equals to minus k, that means 7m is equals to minus k. So k is equals to minus 7m. Now see, we have one more formula, that is alpha into beta is equals to c upon a, 40 upon 1, that is equals to 40. Now alpha 2n, beta 5m. So 2m into 5m, 40. 10m square is equals to 40. That means m square is equals to 4. So we have m is equals to plus or minus 2, taking square root of both the side. Now we have value of k as minus 7m. So we can substitute the value of m now. So substituting m in equation number 1, we get k is equals to minus 7 into 2, or k is equals to minus 7 into minus 2. So minus 7 into 2 is minus 14 and k is equals to plus 14. So we have value of k minus 14 or k is equals to 14. If the roots of the quadratic equation x square plus px plus q is equals to 0 differ by 1. See, the difference between root is 1. Prove that p square is equals to 1 plus 4q. See, the given quadratic equation is x square plus px plus q is equals to 0. So comparing with ax square plus bx plus c is equals to 0, we get a is equals to 1. B is equals to P and C is equals to Q. Now we know, let alpha and beta be the roots of given quadratic equation. And see, it is given their difference, that means alpha minus beta is equals to 1. It is given. Now student, we know the formula. Alpha plus beta is equals to minus b upon a. That is minus p upon 1 is equals to minus p, statement number 2. And alpha into beta is equals to c upon a, that is equals to q upon 1, statement number 3. See, this is the formula. Now see student, we have here alpha minus beta 1, alpha plus beta is equals to minus p and alpha into beta is equals to q. So with the help of this, we have to prove. So we know one relation between this alpha and beta, that is alpha minus beta the whole square is equals to alpha plus beta the whole square minus 4 alpha into beta. See, this is by identity. Alpha minus beta the whole square is equals to alpha plus beta square minus 4 alpha into beta. Now see, alpha minus beta already we have in equation number 1, that is 1. So 1 square is equals to minus p square minus 4q. So minus p square will become p square. See, it is minus p square, square is positive. So we have 1 is equals to p square minus 4q. So we get p square is equals to 1 plus 4q. So hence it is proved p square is equals to 1 plus 4q. So see, by using this identity, alpha minus beta the whole square is equals to alpha plus beta whole square minus 4 alpha into beta. We can prove p square is equals to 1 plus 4q. Find k if the sum of the roots of quadratic equation 4x square plus 8kx plus k plus 9 is equals to 0 is equal to their product. So it is given sum of the roots of the quadratic equation, that means alpha plus beta, is equals to their product, that means it is equals to alpha into beta. Now see the given quadratic equation. 4x square plus 8kx plus k plus 9 is equals to 0. Now comparing with x square plus bx plus c is equals to 0, we get a is equals to 4, b is equals to 8k. Students, see here coefficient of x is 8k, not only 8, it is 8k, and c is k plus 9. So alpha and beta are the roots of given quadratic equation, and see student, it is given very important, the sum of the roots of the quadratic equation is equals to their product. That means first we are going to calculate sum alpha plus beta, and formula is minus b upon a, that is minus 8k upon 4, which is equals to minus 2k. Equation number 1. And alpha into beta is equals to c upon a, that is k plus 9 upon 4. Equation number 2, and c by formula. Now we can write according to given condition alpha plus beta is equals to alpha into beta. Now substitute the value of alpha plus beta and alpha into beta. From 1 and 2, minus 2k into 4 is equals to k plus 9. So by solving this equation, we have minus 8k is equals to k plus 9. So minus 8k minus k is equals to 9. Minus 9k is equals to 9, that means k is equals to minus 9 upon 9. So we have k is equals to minus 1. See student, remember here in given it is mentioned the roots of quadratic equation, their sum and product is equal, therefore you have to consider alpha plus beta is equals to alpha into beta. If alpha and beta are the roots of quadratic equation x square minus 5x plus 6 is equals to 0, first find alpha square plus beta square, and second alpha upon beta plus beta upon alpha. So the given quadratic equation is x square minus 5x plus 6 is equals to 0. Comparing with standard form x square plus bx plus c is equals to 0, we have a is equals to 1, b is equals to minus 5 and c is equals to 6. Let alpha and beta are the roots of given quadratic equation. Now student, we can use formula alpha plus beta minus b upon a, minus of 5 upon 1. So minus become plus, that is 5, and alpha into beta c upon a, that is 6 upon 1, which is equals to 6. So this is by formula. Now to find alpha square plus beta square, we can use identity, that is alpha square plus beta square is equals to alpha plus beta the whole square minus 2 alpha into beta. See, we have value of alpha plus beta and alpha into beta, that is from 1 and 2. Alpha plus beta 5 the whole square minus 2 into 6, 5 square is 25 and 6 into 2 is 12, 25 minus 12 is 13. So alpha square plus beta square is equals to 13. Now see, next we have to find alpha upon beta plus beta upon alpha. Now see student, alpha upon beta plus beta upon alpha, if you solve this, you have to do cross multiplication, alpha square plus beta square upon alpha into beta. Now alpha square plus beta square is equals to 13 and alpha into beta is 6. So we have answer alpha upon beta plus beta upon alpha is equals to 13 upon 6. If one root of the quadratic equation kx square minus 20x plus 34 is equals to 0, is 5 minus 2 root 2. See, one root is given and you have to find k. Now see, the given quadratic equation is kx square minus 20x plus 34 is equals to 0. So comparing with standard form, that is ax square plus bx plus c is equals to 0, we get a is equals to k, b is equals to minus 20 and c is equals to 34. See student, we know that alpha and beta be the roots of given quadratic equation. Now see, one root is given, so let consider alpha is equals to 5 minus 2 root 2. So we can write beta is equals to 5 plus 2 root 2, right? So we can find the value of alpha plus beta now. See, alpha plus beta minus b upon a, that is minus 20 upon k. Minus minus become plus. So 20 upon k, equation number 3. From 1, 2 and 3, see, we have alpha in equation number 1, beta in equation number 2 and alpha plus beta in equation number 3. So we can write alpha plus beta, that is 5 minus 2 root 2 plus 5 plus 2 root 2 is equals to 20 upon k. Minus 2 root 2 and plus 2 root 2 get cancelled. So 5 plus 5 will become 10. 10 is equals to 20 upon k. Therefore k is equals to 20 upon 10, that is k is equals to 2. That means the value of k is equals to 2. See here student, you have to remember, one root is given 5 minus 2 root 2. So the other root will be 5 plus 2 root 2. If one root of the given equation x square minus 10x plus 2k is equals to 0, is 5 minus 2 root 3, find the k. See, this is exactly same as the previous one. The given quadratic equation is x square minus 10x plus 2k is equals to 0. So comparing with standard form, ax square plus bx plus c is equals to 0, a is equals to 1, b is equals to minus 10, c is equals to 2k. See here student, constant is 2k. Let alpha and beta be the roots of given quadratic equation. Now one root is given, so let consider alpha 5 minus root 3, equation number 1, and see the second root beta 5 plus root 3. Now see student, we have to calculate k. So we have to consider now alpha into beta. See, because alpha into beta is c upon a and c is equals to 2k. So 2k upon 1, that is equals to 2k. So by formula equation number 3. Now see, from 1, 2 and 3, we have alpha in equation number 1, beta in equation number 2 and alpha into beta in equation number 3. So alpha into beta, that is 5 minus root 3 into 5 plus root 3 is equals to 2k. Now see student, we can apply a minus b into a plus b. We get a square minus b square, that is 5 square minus root 3 square is equals to 2k. 5 square is 25 and root 3 square is 3. So 25 minus 3, 22 is equals to 2k. K is equals to 11. So we have value of k is equals to 11. If one root of quadratic equation x square plus 6x plus k is equals to 0, is h plus 2 root 6, find h and k. See, you have to find both h as well as k. So student, first we have to write given quadratic equation, that is x square plus 6x plus k is equals to 0. So comparing with x square plus bx plus c is equals to 0, we get a is equals to 1, b is equals to 6 and c is equals to k. So let alpha and beta be the roots of given quadratic equation. See, one root is given, that is alpha is equals to h plus 2 root 6, equation number 1, and beta will become h minus 2 root 6, equation number 2. Now student, we can write alpha plus beta, that is minus b upon a, which is equals to minus 6 upon a is equals to minus 6. This is by formula. From 1, 2 and 3, see, in equation 1 we have alpha, in equation 2 we have beta, and in equation 3 we have alpha plus beta. So we can write h plus 2 root 6 plus h minus 2 root 6 is equals to minus 6. 2 root 6 minus 2 root 6 get cancelled. So h plus s, 2h. 2h is equals to minus 6. h is equals to minus 6 upon 2, that is equals to minus 3. So we have h is equals to minus 3. Now see student, to calculate k, you can use formula alpha into beta is equals to c upon a, that is k upon 1 is equals to k. So alpha h plus 2 root 6, beta h minus 2 root 6 is equals to k. So h square minus 2 root 6 the whole square is equals to k. H square, h is minus 3 the whole square, and 2 root 6 square, 2 square is 4 and root 6 square is 6. 3 square is 9 minus 24. So 9 minus 24 will become minus 15. So answer, value of k is equals to minus 15. So you can write final answer, h is equals to minus 3 and k is equals to minus 15. If alpha and beta are the roots of equation x square plus bx plus c is equals to 0, find the value of alpha upon beta into beta upon alpha. So student, first you have to write the given equation x square plus bx plus c is equals to 0. Now see, this is the standard form only, so you can directly write alpha and beta are the roots of given quadratic equation by formula alpha plus beta minus b upon a, that is equation number 1, and alpha into beta will become c upon a. Now see, to find the value of alpha upon beta plus beta upon alpha, you can solve this by cross multiplication. You will get alpha square plus beta square upon alpha into beta. Now alpha square plus beta square you can write as alpha plus beta the whole square minus 2 alpha beta by identity upon alpha into beta. Now substitute the value of alpha plus beta, minus b upon a the whole square minus 2 into alpha into beta is c upon a upon c upon a. Now solve this. Minus b upon a the whole square will become b square minus a square minus 2 c upon a. Now c upon a comes in numerator, it will become a upon c. Solve the bracket, make the denominator same. We get b square minus 2ac upon a square into a upon c. A get cancelled, so we have b square minus 2ac upon ac. So value of alpha upon beta plus beta upon alpha is equals to b square minus 2ac upon ac.